All right, so for these first four problems, we're going to find the median or the mean, median, and mode of each of these. So let's first focus on the mean. So the mean, also represented as x bar, so an x with a bar on top or a line. So the mean, we just find the sums of the set, you add them all up, and divide by the total amount. So actually, let's do this. Let's be organized, which is a good way to, do your statistics because you're going to get a lot of numbers that you got to keep track of. So let's have a row for the mean, the next row for the median, the next one for the mode. Let's have the sum of x sub I. This is a sigma symbol standing for sum. And let's have the data set sizes. So n. So problem one. I messed up. That's not it. Let's actually erase this with the whiteout. Whoa, whoa, whoa. And above that, problem one, problem two, 3, and 4. Problem 3, and problem 4. Okay, so for problem 1, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 values. Problem 2, we have 1, 2, 3, 4, 5, 6, 7, 8, 8 values. Problem 3, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In problem 4, we got 5 values. So that n is just the number of individuals or values in the data set. Okay, now let's sum up each of these. So the sum of these values for problem 1, 3 plus 5 plus 1 plus 5 plus 1 plus 1 plus 2 plus 3 plus 15 will give us 36. So the sum of those values is 36. Now, the median is just going to be then 36 divided by 4. Let me put that work down here. 36 divided by 4, or no, 36 divided by 9. I jumped ahead. 36 divided by 9, which is going to give you 4. And so the mean here, let's put it in red, is 4. For problem 2, we find the sum, add these values up. So 43, 49, 59, 69, 78, 88, 98, 100, 120, 145, 146, 176. 176. Then we do 176 divided by 8, because the sample size is 8. You get 22. And then we have the sum, 14, 15, 9, 14 plus 15, 19, 22, 7, 37, 41, 51, 55, 65, 65, 90, 132. And don't feel like you got to do them in your head. Just use a calculator. I like doing problems in my head because it makes me feel cool. Now I take 132 and divide it by 10 to get the mean. And that'll be 13.2. And then lastly, for problem 4, we add these up. 21, 28, 38, 43, 53, 63. And we take 63 and divide it by 5. And we should get like 12 something? 63 divided by 5. 12.6. So those are the means of those 4 data sets. Now the median is the value that's in the middle in terms of position. So they have to be in order, like think of it like a race, like the ranking. So let's rearrange them in order. So the first one, the first data set, we put the ones first. So we're gonna go 1, 1, 1, 1, 1, 1. And then we got a 2. You got 2 3s and 2 5s, then a 15. And since we have 9 values, the median is going to be the 5th number. So like the person in fifth place you can think of. So 1, 2, 3, 4, 5. So it would be 3. And the mode is just the number that occurs the most. So the mode here would be just, it could be, you could say 5 and 3. Oh no, sorry, it'd just be 1. Sure. So 1. Because 1 occurs 3 times. All right, then the median for the next data set. And feel free to, pause the video and then try these on your own first and then check your answers because it's usually better to practice. But here I go. Put these in order, find the middle. So 13, 16, 19, 20, 22, 25, 30, 31. And then the middle of these, since there's 8 numbers, like it wouldn't actually be one of the values. It would be between, it'd be like in the middle of the 4th and 5th value, the middle of 20 and 22. So the median would be 21 because 20 and 22 right in the middle, between that would be 21. And since no number occurs any more than the others, you would just say there's no mode, none. All right, problem 3, what's the median? Putting these in order. 3, 8, 15, 15, 15. No, that's wrong. 15, 14, 14, 14, then 15, 15, 15. 14, 14, 14. Then 15, 15, 15. Then 16, and then 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what value would be in the middle place of 10 numbers? Like again, think of 10 racers. It would be the person or the rank between the 5th and 6th place. But it wouldn't be either the 5th or 6th, it'd be between. So the median would be halfway between 14 and 15, which is 14.5. And there's no mode again because none of the numbers. Well, here's actually 2. Then you could say like 14 and 15 are modes, or you can say there's no modes. Either answer is acceptable for my students, and I think most professors will accept either answer, or I guess they'll let you know ahead of time what they want, because maybe they might say bimodal because you have 2 numbers that occur the most. All right, and problem 4, just 5 numbers, so let's go 9, 10, 12, 15, 17. The middle number is just 12, and that's just the number because the 3rd number is in the middle of 5 numbers. So 12 is the median. And again, there's no mode because none of the numbers occur any more often than the rest. All right, cool. All right, moving on to problem 5. Find the value of x if you're given the mean. You're given the mean here. Well, you're given the mean is 6 of these values. So let's look at first what the mean is. In that formula, the mean is the sum of all the x values, or the sum of x sub I divided by n. So we're told that the mean is 6, so we can write 6 equals the sum of these values, which is going to be 2 plus 8 plus 9 plus 7 plus 6 plus x. 2 plus 8 plus 7, no, plus 9 plus 7 plus 6 plus x. And n is going to be 1, 2, 3, 4, 5, 6. So we're dividing by 6. So we're just solving this equation, which shouldn't be too bad, even if you're your first algebra class. So let's go step by step. Let's add the top here. So 2, 10, 19, 26, 32. 32 plus x over 6. To get x by itself, we're going to multiply both sides by 6 over 1, or just by 6. These cancel, and you get 36 on the left is equal to 32 plus x. And then x will just be equal to 4. All right. Problem 6, same type of problem. So let's set the mean equal to the sum of these values. So we're going to set 11.5 equal to 12.5 plus a negative 10 plus a negative 7.5 plus an x all over n, and n is going to be 1, 2, 3, 4, because that's the sample size. And then let's simplify this. So we have 11.5, 12.5 minus 10, negative, or 2.5 minus 7.5, so negative 5, plus x over 4. Cancel is 4 by multiplying both sides by 4 over 1. And we'll get 44, 45, 46. 46 equals negative 5 plus x. And we'll get that x is 51. Cool. All right, next page we got tell whether the data are qualitative or quantitative. So what does that mean? These words sound the same, but this one has an L, and this one has an N, and some T's, and this one has only like a 1 T, and this one's got no, like almost the same, right? So qualitative is just like categories. Categories. So like it'd be like maybe like car brand, like maybe like Mazda, like Ford, Tesla. Whereas quantitative is something that like your heights, your weights, how long you take to run a mile, or stuff like that. We like you can measure it on a numerical scale that is continuous. So what would be quantitative? How would you measure each one you want to think of? Well, you'd measure the heights of the members of a basketball school, by maybe using inches, feet, but on a quantitative scale. This is quantitative. Quantitative. This is like a brain twister question. So quantitative. Grade level students in elementary school. Now this is a good one because you may be thinking like, well, you could be in first grade, second grade, third grade, fourth, fifth, and kindergarten, right? And then you're like, well, there's numbers. Well, kindergarten, the letter, like how does that work? Well, these are still categories. Like sometimes we can have categories fall into a name or belong to a group where the name or the group, title is like a number. Like maybe you're an 11th grader. but you're also a sophomore or a junior. That's not really, you're not really measuring something and getting one, like in the sense that like all first graders, like they're all just in that group. They're all first graders, and we're not measuring like their heights or something like that. These are just group names. They're just names. So then this would be qualitative. Little check mark there. All right, next we have cat lengths, where we have to find the range, standard deviations, and 5 of them are summary for each of these. So what's going on here is we just want to find some values of these are statistics. So let's just start with the simplest ones, and then let's figure out what the other ones would be. So let's look at just like the cat lengths. Well, I guess yeah, cats have height. I don't know. They measure them from tail to head or something like that, whatever. Well, let's put them in order. Put the data in order first, because that's always a good way to start and know that you're not gonna organize an organized way, and a way you can spot all the key characteristics or key stats. So we're putting them in order from smallest to largest. 25. And we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So n is 8. Now, the 5-number summary, we use these fancy brackets, is the minimum, maximum. Well, let me just write it, I guess it's a review. Minimum, Q1 in order, then we have the median, then Q3, and then the maximum. We call it the 5-number summary because there are 5 numbers that are actually quite helpful for describing the data, as well as being simple numbers to find. So start off with the minimum and maximum. And I would say, well, you can start off whatever, but the median, max. Minimum is 16. So 16. Maximum is 25. 25. Minimum or like median, let's say, middle. So since there's 8 of them, the median will be between 20 and 21. So the median will be 20.5. 20.5. And then Q1, just think of like the median as the first half. So Q1 would be in here between 17 and 18, which will be 17.5. And then let me put a Q1 down here. First quartile, the first 25% of data. And then third quartile would be like the median of the second half. So the median of these 4 values. So halfway between, or right in the middle, 22 and 23 will be Q3. And that's going to be 22.5. Should have left more space, but there we go. So that's our 5-number summary. Dun, dun, dun. Now the range is simply the distance from the maximum to the minimum. So the range will be equal to 25 minus 16, which is going to be 9. And probably, as you already know, this just tells you about how much difference or how much variation there is between the largest and smallest values in a data set. The cat lengths vary by 9 inches. And now let's get to the fun standard deviation. So the standard deviation is a great and powerful and popular measure of spread. For samples, we typically use a lowercase s. And that's going to be equal to the square root, where Inside the square root, we have the sum of the squared deviations. So the sum of the squared differences of the values from the mean. So xi minus x bar, how far each value is from the mean value. And since it's a sample, we divide by n minus 1. And that's due to correct for accuracy since it's a sample size, but that's a more complicated topic and I'll talk about it in another video if you'd like. So we have to just understand what this is. Like it's actually pretty simple. It just could be tedious if you have a lot of data. So I like to always recommend having a table, and so it'll be a nice way to organize it. So let's do this. Let's have in your first column xi, and the next one will be the difference between xi and the mean. Then we find the differences squared, or the square deviations. So xi are quite literally just the values. And we say xi because we could say this is the first x1, x2, x3, x4, x5, x6, x7, x8, and so forth. So let me just write that out. So x1 is 16, x2 is 18, x3 is 20, x4 is 25, x5 is 17, x6 is 22, x7 is 23, and x8 is 21. So these are the values. Now to find the mean, well, we need to find the mean next, which is just going to be what we've been doing, add these all up, divide by the sample size, or 8. So let's do that, yeah? So 16 plus 17 plus 18 plus 20 plus 21 plus 22 plus 23 plus 25 divided by 8. The mean is 20.25. So let's write that over here. X bar is 20.25. Okay, so then we just have to calculate how far these values are from 20.25. That's quite literally what this is. You can do a lot of these by in your head or use a calculator if you want, but it's always more fun to try them in your head. So 20.25 minus 16. So this is below, so that's why we have negative 4.25. 18 will be 2.25 below. 20 is only 0.25 below. 25 is above, 4.75 units above. Let's keep it going. Negative 3.25. 1.75 above. 2.75. And then 0.75. And then we just square these values. We quite literally take these values and square them to get these values. So 4.25 squared, 18.0625. Now, just depending on how accurate or where you want to round, it's just a question of what your teacher, professor, whoever is making you do this, want how accurate they want it. And these are always going to be positive because a negative times a negative is a positive, positive times a positive is positive. So let me just run those out. Mm-hmm. 3.0625. 0.5625. There we go. Now the sum of these. So let's just find the sum of these. That's what's going to go here. So breaking this down, adding these all up, being focused so we don't want to make a mistake. So 18.0625. No, I already messed up. 0.0625 plus 5.0625. Will I keep on missing 65? Plus 0.0625. Plus 22.565. Plus 10.565. Plus 3.065. Plus 3.0. Plus 7.565. Plus 7.565. Plus 0.5625. 67.5 is the sum there. Cool. Got that correct. Divided by n minus 1. N is the sample size, which is 8. So at 8 minus 1, we're going to divide this by 7. Now don't make the mistake of square rooting before you divide. So we take 67.5 divided by 7, and we take the square root of this number. So we want to find the square root of 9.642857143 approximately. Doing that, we get about 3.10. Or I can say 3.11, I guess, in this case. All right, so what does that even mean? Well, standard deviation is a measure of spread. It gives you an idea of how much variation there is within the values. Range tells you exactly how much range there is or how much difference there is in total from smallest to biggest. Variation or standard deviation is, again, and within the data set. So like this 3.11, we basically can think of it as the average distance that the cat length is from the mean length. Let's write a sentence. I'll say that the cat lengths vary by about 3.11 inches from the mean cat length, from the mean, which in this case is what was 20.25 inches. So the cat lengths vary by about 3.11 inches from the mean cat length on average. There's more to it, and we'll get to that when we start doing normal calculations using normal curves. But that's how you want to think of it. Make sure you understand it's just a measure of spread that gives you an idea of how much variation there is within the values. Cool. All right, moving on. We are now going to be looking at making two-way tables. Yay! We got that in this situation, we are conducting a survey that asks 245 students in your school whether they have taken a Spanish or a French class. 109 of the students have taken a Spanish class. 45 of those students have taken a French class. 82 of the students have not taken a Spanish class or a French class. Organize the results in a two-way table, including the marginal frequencies. Yeah, not a problem. So we call it a two-way table because we got two ways to look at it. Up and down, left to right. So we got the columns or the rows. In this case, I'm drawing the rows first for whatever reason. We got the columns. Categories, kind of one category here, the other one here. So we're gonna go by, for no particular reason, whether or not they spoke French or took French. So like French, they take French. And here's gonna say whether or not they took or answer. We're gonna have, did they take Spanish? The question mark. Espanol? We're gonna put yes, why, and no. Here we'll go yes, sí, or no, no. Let's fill it in. Total. Remember the totals go on the bottom and right in those columns. I like to work from the totals inward or outward, however way you think about it. Or so the total is 245, bottom right. So it's right here. And we got 109 of the students have taken a Spanish class. So where would the total Spanish class be? Where would it be? Well, right here. Spanish, yes, 109 total. Now it's like, and 45 of those students have taken a French class. So 45 of those Spanish students have taken a French class. So out of these 109, 45 of them we would put here because that's a yes for French. 82 of the students have not taken a Spanish class, so no Spanish. So no Spanish, just here. No, sorry, checking something. 82 of the students have not, 82 of the students have not taken a Spanish class or a French class. So no and no. Where does no and no appear? Right here. We just got to finish the rest. It's just a game. So what you would put here is what adds up to 109 when you got 45, 55, 60, 64. 64 plus 82, 146. What plus 146 is 245? 99. See how fun this is? What plus 45 gives you 99? 45, 54. 54 plus 82 is 136. Bang, we're done. Not a problem, simple. Okay, let's do one more. Making two-way tables. A car dealership has 98 cars on its lot. 55 of the cars are new. Of the new cars, 36 are domestic cars. There are 15 used foreign cars on the lot. Organize the information in a two-way table. Include the marginal frequencies. And more practice, yeah, let's start at the same. Bang, bang, bang. 9, 9, 9. One category here, one category there. Doesn't matter which one is which. We're breaking this up by condition. Where, in other words, you have a new or used car. And here we're going to be like, are they foreign or are they domestic? So we can maybe say origin. So let's go foreign over here. And domestic here. And don't forget the totals, remember? Total. And we just fill it in. Car dealership has 98 cars on its lot. So a total of 98. 55 of the cars are new. Total new, 55. Of the new cars, so this column here, 36 are domestic. Bang, 36. There are 15 used foreign cars on the lot. So used and foreign. So used and foreign, bang, bang right here. Let's finish this table up. So what adds up to 98 when you have 55? 43, that is correct. 15 plus what is 43? 28. 28 plus 36. That's right, you guessed it, 64. What plus 64 is 98? 34. What plus 15 is 34? 15, 19. There we go. Another problem solved. So let's keep it going. All right, let's look at some more of these types of tables where we're organizing frequency. Now we're going to look at when we're given the counts, we say, let's figure out how we can make a joint. Well, we know we're given a joint. Let's go over what marginal relative frequency means. It sounds complicated, and it is. I'm just kidding. It's actually pretty simple because it's just interpreting these values in percentiles or percent or proportion. So like I'm wondering if I should just draw a whole new table. I don't want to be lazy though, but I'm not going to, because I think this will be very efficient. I think I can do it without drawing another one. But let's go like this. Let's actually break this down, because it might actually be helpful if we look at the totals first. So we have this table, and we got types of exercise performance or preference, aerobic and aerobic. So like intense, and whereas other is more endurance, and gender, male, female. So what's the total or total? Well, let's first add all these guys up. So 88 plus 104 plus 96 plus 62, 350. That goes here. And we figure out the rest by just adding across. 88 plus 96, 184. So to get 350, you would get what? 116, 176, right? 1 plus 176. No, yeah, 166. These two added together, 96 plus 62, 158. That would be then 192, right? 350 minus 158. Yeah, 192. Okay, so now when we were talking about marginal relative frequencies, look at these values and in terms of what percent of the total they represent. So like this guy, the 350, that's everybody. That's 100% of the total. 100%. Now, sometimes they may be looking at 1.0 as a proportion, but I'm going to write them in percents. Or should I? Yeah, let me go with percents. Because it's really not that big of a difference. So let's look at what would go here. So 166 is what percent of 350 is 166? So we just divide 166 by 350. We get about 47.42, which is about 48%. And actually I changed my mind because I want to make sure I don't confuse you guys. Like they're gonna want like a number as like a decimal. So 0.48 will go here. Now, since we rounded, that means this would have to be whatever you add to get 1 or 100%. So 0.52. The 0.52 of the data is in this column, 0.48 of the data is there. Now, what percent of the total data is here? So then we just take the 96 divided by 350. And we got about 27% or 0.27. So we'll just put a 0.27 here. Then it's like, what about what would go here? Well, what number plus 0.27 gives you 0.52? That'll be 0.25 or 25%. And we just work our way through. 152 is what percent of 350? Did I say 152? I mean 158 divided by 350. About 45% or 0.45. What plus 0.45 gives you 1 or 100%? 0.55. And we just work our way through. So then this would then be 0.3. So 0.18. So when they say have a relative frequency table, it quite literally is basically, instead of having the values that we had in black, it would just have the values in red. Like it would have those instead. Those give you like a sense of what proportion of the total lies in each of those boxes. So let's go back to this one to get a better idea. So going to this problem is what percent of students prefer aerobic exercise? So aerobic exercise, what percent of students prefer aerobic exercise? So what percent of students are here? Well, this is the column for aerobic exercise, and that'll be 52%. Because that's what we just figured out. 0.52 is all here. What percent of students are male who prefer anaerobic exercise? So it's just saying like male and anaerobic. What percent of everybody is going to fall into the male and anaerobic? So this guy, it'll be this box right here. That's your winner there. So that's a 0.3 or 30%. Yeah, nothing too complicated. Bang, bang. All right, near finale. All right, so let's do the same thing for here. Get the turkey and meat, or what the sandwiches from the meat and the bread, or yeah, the type of meat is turkey or ham, and then the type of bread is white or wheat. Yeah. Well, let's add these guys up as we should to find out the totals. Go from there. Okay, so adding everybody up. Dun, 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 we would go and get 452 plus 146 plus 328 plus 422. 1348. Four five two plus 328. 780. 146 plus 422. 146. 568. 328 plus 422. 328 plus 422. 452 plus 146. 598. Simple enough. Now let's convert these to relative percent or relative proportions. So again, this is 100% or the 1.0. What does this make of the total? So we just take 780 over 1348. about 0.58, we'll say, or yeah, let's just keep it, let's take it to 0.58. 0.58. If we're gonna go with 0.58, this would then have to be 0.42 because these two have to add up to 1. Now let's work our way into the inside. Or let's work our way from, let's keep the outside. 750 divided by 1348, 0.56. 0.56 plus what gives you 1? This would then be 0.44 from that. Now let's work our way through. 422 over 1348. Let's go with the 0.31. And then we can figure out the rest by just adding. 0.31 plus 0.11 is here. 0.31 plus 0.25, so this would be 0.25. And then what plus this, or whatever, however way you want to look at it, 0.33 plus 0.11 is 0.44. So there we go. Now the follow-up question, refer to exercise 18, or what? Or this is supposed to be 16, this is 18. 16, that should be 15. What percent of the sandwiches are on wheat bread? Well, that's simple. It's just gonna be this value because this is all the wheat sandwiches. Yeah, see how easy math is? 56%, or I should say stat. I don't know why I put a question mark there. 56%. What percent of the sandwiches are turkey on white bread? So turkey and white bread. So turkey intersecting with white bread, right here, the 33 percentile. All right. And there we go. So I hope that helps. Like, feel free, please give me feedback. If I did a bad job, let me know. I don't want to do a bad job, but you know, I'm still learning. But if I did a good job or you found it useful, hit that thumbs up, that like, subscribe, and you know, let me know what other content you want to me to focus on, and please leave a comment if you have any suggestions or any feedback. But I will see you guys in the next video.